Hey guys, this is Carrie, and this is the answer key video for homework number 2 in Unit 10. So yesterday we talked about regressions, today we're talking about systems of equations. So follow the following system of equations algebraically. So we've only learned one method so far, and that is the substitution method. And we're really lucky. This first equation that we encounter, we've already solved for y here, so we can just substitute this expression in for y there. So this leaves us with 2x plus 1 equals x squared plus 4x minus 2. Now this equation, with the star next to it, is significantly better than our other two equations because we only have a single variable x that we're trying to isolate. There are no y's in this equation. So because there's no y's, we just solve it like normal. Minus 2x, minus 2x, minus 1, minus 1. 0 equals x squared minus 2 plus 2x minus 3. This is a sum and product factoring problem, so x plus 3 times x minus 1. 3 and negative 1 sum to 2, 3 and negative 1 multiply to negative 3. And the two solutions that make this equal to 0 are x equals negative 3 and x equals 1. I put a box around that. That's not correct. To solve a system of equations, we need to find not just the x values, but the y values. We need all of the unknowns. So if x is negative 3, what we can do is we can use the second equation here, y equals 2 times negative 3 plus 1, plugging in negative 3 for the x value here. And what that will do is it will allow us to find the y value that corresponds with this x value. So now we've got our y value. But the final solution for this set will be this point and the point that we get from x equals 1. So let me erase this line and move that over a little bit. From x equals 1, we're going to get, let's see, y equals, substitute 1 in for x here, 2 times 1 plus 1, y equals 3. So we have our two solutions right there. You might think, well, why are we getting two solutions to a problem like this? And I think when we look at these problems graphically, you'll notice that this is a parabola, this is a line, and a line and a parabola often intersect at 2 points. Those will be the solution, and this will definitely help us in a future class. Oops, wow. I'm getting used to the new iPad update. It's a little bit different. All right, so now for problem number 2, solve the following system of equations below, and we are going to be using the substitution method, but we have a problem. We are not given any equations that can easily be substituted like we had before. So ease of substitution comes from the idea that here y was already isolated. So although we have no problems where y or x are isolated, we do have a pretty easy equation in equation number 2, where we can easily isolate x or y in this equation. So from equation 2, let's start by isolating. You can pick either x or y, it's your choice. I'll pick x because we did y last time, so let's isolate x. So we start off with x plus y equals 3. To isolate x, we're one step away, minus y on both sides. X equals 3 minus y. You could also write that as x equals negative y plus 3, and I like this one better. Now the benefit of having this equation, I keep boxing it, it's not the final answer. The benefit of having this equation, I'll put a circle around it, is that now we can take this equation and substitute it into our other equation. So substitute this starred equation into equation 1. And this actually turns out to be really nice for us. Let's see why. We get negative y plus 3. Maybe there's two sets of parentheses here at first, plus 2 squared, plus y minus 4 squared equals 25. And so we've taken y minus 3, and we substituted that for the x right there. Now, there's nothing to distribute in front of the negative y plus 3 that we just underlined, so we can drop these parentheses here and here. Now this becomes negative y, combining like terms, plus 5 squared, plus y minus 4 squared equals 25. And now it becomes a giant distribution problem, but it's not too bad. Let's see. Negative y plus 5 times negative y plus 5 plus y minus 4 times y minus 4 equals 25. And we need to distribute here because when we square something, it means that thing times itself. So let's do it. Negative y times negative y is y squared. Negative 5y, 25 plus y squared, negative 4y, 16, 25. Combining like terms gives us 2y squared. Negative 10y minus 8y is negative 18y. 25 plus 16 is 41, and that all equals 25. So this color is getting a little hard for me to read. I am going to switch to purple because I think maybe that will be a little easier to read. We'll subtract 25 on both sides. That gives us 2y squared minus 18y plus 16 equals 0. And we'd want to use the same technique we used to factor this problem, sum and product. But with the 2 here, we can't do that. But we are really lucky. All three of these terms, 2, negative 18, and 16, are even. So we'll divide by 2 on both sides. 2y squared divided by 2 is y squared. Negative 18y divided by y is negative 9y. 16 divided by 2 is 8. 0 divided by 2 is 0. And this is really nice for us because now it looks exactly like a sum and product problem. So two things that multiply to 8. Well, usually you'd think 4 and 2, but those don't work with negative 9. What does work with 8, though, is negative 8 and negative 1. So now, when we solve for y, we get two solutions, y equals 8 and y equals 1. All right, so a little bit of an advanced technique here that I think you guys might like. It saves a little bit of time. Is often we go into one of the original two equations to solve for x or y, and you're totally welcome to do that now that we have our two y values. But I noticed that we have this nice start equation right here where x has already been isolated. We can actually use this equation because it's equivalent to the second equation, and that will allow us to find x more quickly. So let's use this equation right here. So if y equals 8, to get the x value, we say x is equal to negative what we got for y plus 3. X is equal to negative 5. So we get 2 points, or 2 coordinates, negative 5, comma 8. And then over here, we use the same equation. X equals negative, we got 1 for y, so 1 for y, plus 3. X is equal to 2, and we get 2 comma 1. So we have two solutions again. Now, for this one, the graphical picture is actually interesting as well. If we think about these two equations, I'm going to erase some of the extra text here now, so we can get a nice picture of it. You might recognize this equation from geometry class. This is the equation of a circle. And if you really paid attention in geometry class, you'd know that it had radius 5, because 5 squared is 25. So we've got a circle. I don't know where it is. Well, it actually is somewhere like there. You can actually find that exactly by thinking about geometry class, but that's for another topic. And we've got a line here, x plus y equals 3. And if you think about a circle and a circle and a line are oftentimes going to meet at 2 points. And that's why you get two separate solutions for our system of equations. I hope you found this video helpful. It definitely was a lot quicker than when we did these in class because I'm not asking as many questions. So hopefully that illustrated that these problems are not as long as maybe they seemed in class today. See you tomorrow, where we'll talk about the elimination method for system of equations. Have a good night. Bye.